This question is about electromagnetic induction and specifically the EMF induced in a wire as it moves through a magnetic field. Now, I found the diagram on this one a little bit confusing and it actually needs a little bit of thought to understand what's going on. So we have the vertical conducting rod. So we've got a conducting rod and the length of it is L. And then we've got some magnetic field lines and this is a side view, and we're told that this is my conducting rod, so we'll have an EMF going through here. And if the wire is moved parallel to the field lines, we'll get no induced EMF. If it's moved so out of the page, then it will cut through field lines. If it's moved up and down, well, it will cut through field lines, but the area through which it's cutting is it ends up being infinitesimally small. So we're really interested in the horizontal motion as it is moved at right angles. So horizontal motion could be along the field lines, or horizontal motion can be in or out of the page or the screen. So we're given those, and then we're asked to find the induced EMF. Well, the induced EMF is given by the rate of change of flux linkage. So the EMF given is rate of change of flux linkage, and that will be in the formula book, and we'll get the exact notation within the formula book. So we're looking for magnetic fields. We have magnitude of induced EMF. So they've put the magnitude, and that's why I was pausing to check this. It says magnitude, so we're not worrying about the sign convention here, where generally speaking it would be negative. But we're told that it's the magnitude of the induced EMF. So the magnitude of the induced EMF, number of turns, that's not relevant for this one because it's just one coil of wire. And then we've got the change in flux per unit time. But the change in flux is, and it's a uniform field, so the change in flux is the change in, and that can be expressed as BA, but B isn't changing. So it's the change in area per unit time. Now the area being swept out, if we've got a velocity, and this doesn't really work with this diagram, but if we've got a velocity coming out of the page like this, then the area swept out per second, which gives us this unit time, the area swept out per second is given by VL, because as it moves through V, it sweeps out an area every second. If it goes through V in 1 second, it's gone a distance of V in this direction, and it's swept out a side length of L times V. So that's the area swept out. So we end up with the EMF being equal to BLV or BVL.